Let's get started then. Yo, what's up, everyone? Welcome back to the Pioneers. Well, welcome back if you've been here, previous semesters, and welcome for the first time if you are, just now joining us. Yeah, so in this meeting, the first 10 minutes, we're just gonna go over like the general overview of this section of the club, what we're gonna be doing this semester, essentially a rehash of the information meeting in case you didn't see it. And then I'm going to pass it on to Philip to introduce you guys to Python from scratch. So yeah, let's just get started. All right, so essentially what the Pioneers is that our section will teach you guys data science and machine learning concepts that you guys are going to utilize to code up a project in Python that's going to solve a problem utilizing machine learning. And one of the most important things about this section is that we zoom zero experience with either data science or machine learning. So you don't have to worry about any of that. We're going to be teaching all that stuff. Next slide, please. Yeah, thank you. This is pretty much the same thing I just said in the previous slide. With regards to prior knowledge, yeah. The only prior knowledge you will be needing, well, not needing, but we assume you have, is basic experience in any sort of programming language. It can be like, Java, C++, Ruby, OCaml if you're feeling spicy. But yeah, just basic programming skills like loops, functions, arrays, basic stuff like that. That's all we're going to be assuming. But we are going to be teaching you Python from scratch. Yeah, so I mentioned earlier that we're going to be eventually coding up a project, final project at the end of the semester. So just to give you an idea of what those projects could be, in the past, in fall 2020, we made a deep learning model called a CNN, which would detect whether a human cell, like a picture of it, was infected with malaria or not. And then spring 2021, we used a logistic regression model, which is just another type of machine learning model, to predict whether a given employee would quit their job given their characteristics and whatnot. So yeah. So this is a very rough and not set in stone schedule for the semester. As you can see here, we've kind of divided up in two parts. So the first half of the semester is where you're going to be learning the majority of the concepts and like just learning the basics of what machine learning and data science, all these different techniques are. So we're going to be teaching you Python from scratch. Then we're going to be introducing you how to handle data, because data is kind of like the core of machine learning. How we're going to, clean up data, handle null or missing values, how we're going to manipulate data, how we're going to visualize data to make it easier to understand patterns and trends. Feature engineering is a big part of it too. And then like in the week of February 28th, this isn't set in stone yet, but we're planning to have a guest speaker who is a UMD grad with experience in both industry and research to give like a sort of talk about machine learning. And then, yeah, just gonna be teaching more data stuff. And then we're gonna introduce you to the general machine learning pipeline, which we'll get into detail later. And then the second half semester, we're going to be, going to the more specific machine learning models. This semester, we are going to be going over decision trees, random forest. These tree-based models are sort of the most used and applicable machine learning models in the industry, arguably. So, and are pretty easy to understand for beginners. And then we're going to be, understanding how we measure accuracy, how we measure how good these models are. And then somewhere in April, we plan to introduce the final project to you guys, where we're going to divide you guys up into teams of, I think, up to four people are going to do it this semester, and you guys are going to work together to solve a problem using machine learning, all the stuff we've learned. Then we're going to conclude, and we have like a buffer meeting, and what that means is that we have one extra meeting that we'll either be using, or, well, if we for some reason miss a meeting in between due to some catastrophic reason, we always have one extra meeting to make up so we don't fall in place. So yeah. Table contents. Wait, I believe I may have like misplaced the bio somewhere, but I mean, it's not that important, but still.
Do you want me to go hunt? Do you want me to go hunt for it?
If you want to, sure. You got time.
There we are.
Oh, there you are. Yeah, so I probably should have put this at the beginning, but yeah, just so you know who I am. I am Simrat. I'm going to be one of the leads of this section. I'm currently majoring in computer science, doing machine learning concentration. This past summer, I was a software engineer intern at Capital One, and there I did stuff with Python, machine learning, some DevOps stuff. Fun fact, I actually did use decision trees in random forests, so just goes to show how it's applicable. Yeah, and the fun fact about me is that I'm the guitarist for a rock band forming UMD, Unity for the Outcasts. I'll probably send you details about that sooner or later. But yeah,
they're really good. Go listen to him on Spotify.
Of course. And one thing I just wanted to emphasize is that I actually came into UMD not being a CS major. I was a marketing major out of all things. So I kind of can relate to people just trying to get into the whole CS tech space for the first time. And I just want to state here that I believe anyone has a capacity to do stuff like this and succeed. It's really just a matter of the amount of effort you put into it and your mindset. And coming from someone who did not have a STEM background yet was somehow able to plow through CS3 through sleepless nights. I just want to say that if you ever have questions or doubts in anything, whether it be this club or CS, because like CS is hard, your major, just don't feel free to DM me or the other leads. We're here to support you. Most of us here are like juniors and seniors, so we're about to say bye-bye to UMD. So yeah, just know that this section here, use it as a support system if you need to. Yeah, that's pretty much it. And with that, I will pass on the baton to my guy, Philip. And yeah, I'm going to be teaching you guys Python from scratch today.
All right. Hello, everyone. As Samrat said, my name is Philip Matthew. Please just call me Phil. Philip's my grandpa. So, I'm not 70 years old yet, at least. So before I start talking about myself, I'm first going to go over a quick bio of who I am. Then after that, I'm going to go into, what machine learning / artificial intelligence are, try to define these very, very, very high level concepts. Then we're going to start jumping into, Python. And as we do Python, as well as at the end, there's going to be like a quick exercise where I'm going to throw up like a collaboratory notebook. If you don't know, you'll figure that out very soon. And I'll essentially I'll give us a task and I'll ask you guys, to tell me how to code it up, given what I've taught you so far. And at the end of this, which will become a theme with all of the rest of the meetings of Big Think, we'll have a time for Q&A at the end. Feel free to ask me any questions. And as Samra said earlier, we're all here to help. As CS is hard, and for a lot of us, or for a lot of you, this may be your first experience with artificial intelligence, and you may be wondering, not just how do I use any of this code, but specifically like, other things that are just like life questions, like how am I supposed to get an internship? How do I demonstrate to, other employers that I actually know this stuff? And so, or, the one common one, how do I format my resume and how do I put Big Think on my resume? Stuff like that. I'm happy to help. The rest of the leads are always, as Samrat said, happy to help. So in general, if you just have any questions, you can ask us at the end of the meeting or, DM us on Discord, whatever. But moving swiftly along from all of that, who am I? Well, as I said earlier, my name is Phil Matthew. I'm a computer science and applied math double major here at the University of Maryland. I have also been, for the past 3 to 4 years, I've been interning at the Johns Hopkins University Applied Physics Laboratory's Intelligent Systems Center. We call it APL for short, because who the heck wants to say that many words in one go every time you talk about your job? But yeah, at the ISC, I can talk about that more at the end if anyone wants to. But in general, I work in artificial intelligence research, specifically focusing on computer vision tasks. And so far, the work I've published has been aimed specifically at medical tasks. So another thing is also on the AI lead here at Big Think AI. And fun fact is that I actually enjoyed Cyberpunk 2077. I know that's weird, but somehow I was able to enjoy it and I found it to be a fun game. So If you disagree, I don't know, crucify me somewhere or the other, but it was a fun game, okay? But yeah, with that said, let's jump right into the meat of the lecture, or well, meeting really. So what is machine learning and artificial intelligence? Now we've listed all the definitions here, and I'm not gonna reread them because I trust you guys know how to read. But in general, the most important thing to know is that artificial intelligence is kind of like an umbrella term to describe just computers acting somewhat human-like. So to give some quick history, back in the past, actually, people thought that compilers were, an example of AI because, it's a computer taking scripts or programs and translating it into machine code the way that a human would, and then running that on a computer. Now, obviously nowadays we think of AI and we don't think of a compiler. We think of a compiler as just like a normal part of every sort of programming language, or well, every sort of system really. But, that goes to show that AI has this changing definition all the time of what specific technologies involve AI. So it's kind of just a general term for computers acting in a human-like way. Now, going more deeper into that, machine learning, which is the crux of what we'll be talking about for the entire semester, is specifically refers to the set of algorithms that are able to learn from examples without being explicitly programmed. And the without being explicitly programmed part is the key there. We're not specifically telling it, hey, if you see this specific thing, then do that. We're simply giving it data and saying, make something out of that. And it will eventually learn that, okay, if I see this, I need to do that, and so on and so forth. And then if we want to go further, we'll talk about this later, but deep learning is specifically focusing on neural networks, if you guys have heard about those. So it's the type that is the stuff that really goes into neural networks for image detection or segmentation and all of those different applications. Again, all of us would love to talk to you guys about this if you have questions later, but for right now, knowing what deep learning is just think neural networks really. But yeah, so another thing that we put here also is that machine learning, as Yufeng Guo says, is using data to answer questions. And I have an example right here is that we can see that we have data here. This specifically comes from data of passengers on the Titanic. What we have is a bunch of different attributes of whether or not of these passengers, so what their ticket number was, whether or not they had siblings, all of that stuff. And what the idea is with machine learning is we take data like this, and if we give it to a computer, we say, hey, based on these attributes, exclude the survived column, but based on the rest of the attributes, can you tell me whether or not a given passenger survived? And the idea is that the computer will use a number of different algorithms. We'll show you the specific ones along the way, but there are multiple different algorithms it'll use to try and pick out, okay, this person survived, this one didn't, and figure out the trend that can relate, whether or not a person survived with whether or not they belong, different things like, what their gender was and what their age was and all of those other attributes. And so that's just a hands-on example of, again, as I said, what machine learning is, where we just take data, we throw it at a computer, and it uses its algorithm to then figure out, okay, this is the trend, this is the relation between between the input that you're giving me and the output you want me to predict. And it will use that to try and, act in a human-like manner and predict outcomes based on other inputs that we're given. So specifically what we'll be teaching you in this what we'll be teaching you in this club for the semester is this entire pipeline. So the pipeline for machine learning usually starts with data collection. That part we're not going to go into because it's literally just picking up some data and grabbing it. After that, you then need to process your data in some way, which we'll be talking about not today, but we'll talk about it soon. And basically, how you go about taking your data and getting it into a nice format for your machine learning models to use. From there, you then take your data and you put it through a training cycle where you feed it to the algorithm. The algorithm makes a prediction. You check how wrong the prediction is, and then you fix that. And you just do that over and over. That's what training is. And you just continue to do, as I said, you just continue to do that over and over until you get a good model. From there, you then take your model, you run it through a testing stage where you figure out, okay, is it good or not? And then you deploy it in some way. So as I said earlier, we'll take you through every stage of this pipeline and we'll teach you how all of it should work. Now, oh my God. Okay, so now why are we using Python? So for those who aren't familiar already, Python is a very simple language with easy syntax. And the thing is that machine learning models themselves are complicated enough. We don't really want to add extra complexity to them. So that's why the de facto standard for languages in this field has become Python. Now, that's not to say you cannot use another language. JavaScript is usable, C++ exists, Java exists, obviously. There are languages that support machine learning, but for this club, and really in general, the main language used is Python because it's really easy to type things up quickly, and then you can test them out and figure out what's going on. So you don't have a lot of time where you have to think about, okay, how do I code this in terms of just, how do I code this given, specifically with C, like how do I free up memory and stuff. You just need to worry about, okay, cool. How do I write this down? Write it down in Python and then just run it and it figures itself out. Also, another thing that came as a consequence of this really, but another thing that's good about Python is that it has a lot of libraries. So if you've ever heard of words like TensorFlow or sklearn or pandas or stuff, or PyTorch even, all of these libraries are designed usually for Python. And the thing that makes Python great is that because it can interface with all of these, it makes it very seamless to take data, bring it in, manipulate it in some way with your code, and then feed it into a machine learning model, and then put a prediction. So it allows you to do everything without having to jump through a lot of hoops. And the other thing is popularity. Now, for those who have done CS for a while, you'll know that popularity of a language doesn't really mean much. Like, there's a lot of people who love Haskell, but it's obviously not a popular language. But the good thing about Python being popular is not that, oh, people like it. It's that since it's popular, if you encounter like some sort of weird bug that you're not entirely sure about, there is more than likely some sort of example of someone encountering the same bug on the internet and being able to figure out the fix for it. So if you don't know how to write a piece of code and you're getting errors and you're like, what is going on? You can type it into Google and you can get Stack Overflow answers or, other things like that. And you'll be able to fix up your problems easily without having to worry about, okay, do I even know if people have run into this problem before? So yeah, that's why we use Python. So with that, I'll start jumping into Python syntax. So quick differences with Python and Java. Well, this is mostly due to the construction of the language, but the main point here is that in order to just get up and running with Python, there's very little typing that's required. So like with Java, you need to type in, public static void. You need to define your main method. You need to put all that stuff down. You need to do system.out.println and everything. Python doesn't really have this whole idea of a main method. There is a main method, like in terms of just like a language style, but there's no, like in terms of like the actual like functioning of Python, you don't require a main method in order to run anything. So you can just type print whatever, and it'll just get up and running. And also another quick difference, which you guys can probably see from there, is that we don't need semicolons in Python. I will warn you, semicolons are a valid thing in Python and they can be used to terminate lines. If you do that, I don't know, you'll unleash the wrath of me or something like that. Don't use semicolons in Python. They're really not necessary. But yeah, so in terms of Python, now for the rest of this talk, what I'm going to be doing basically is I'm going to be quickly switching between the slides and like a Colab notebook, which is where I'll be running things so I can like show you like a hands-on example of what's happening as I teach you the syntax. But in general, we'll just start from here. So variables in Python. Well, how do we store data into variables? Well, in Java, as we know, or in most strongly typed languages, we need to do, or static, I think static typing is the term, but yes, statically typed languages, you need to do string, whatever, YOLO, and then you need to put the semicolon, and you need to define the type, you need to put the variable name, you need equals, and then the value in it. A little too much typing, kind of makes my fingers hurt. So what we do in Python instead is just you put the variable name and you put the value that goes in the variable. And Python's interpreter or whatever is running your Python code will figure out exactly what that type of that variable is, and as a result, what methods can be called on and all of that stuff. But in general, you don't need to do any sort of like, type declaration or whatever. So if we go here, if I just want to type in, say, let's say I want to create a variable Phil, or a variable that stores my name. So I can just say name equals Phil. And we can then see that when I want to print the name at the end, if I can, capitalize things correctly, it just comes out with my name, Phil. If I want to say, ID equals 1706, and you can, again, and things work out like that. And again, Booleans. Oh yeah, another thing with syntax with Booleans, which is kind of important, is that, let's just make is true Boolean, even though that's kind of a dumb name. Boolean specifically, in a lot of other languages, you type it like that, true or, false. As you can see, nothing's lighting up, which means that that's not actually how you type Booleans in Python. Python want it to be special, so you have to capitalize them. So you type true that way, and you type false that way. And yeah, just remember that it'll come up eventually. And if you're migrating from another language where you don't capitalize them, it can kind of be a pain. But just remember that in Python, you capitalize your booleans. But yeah, that's essentially how you make variables. It's just, variable name, assignment, and the value of the variable. Now, conditionals are the next thing we're going to talk about. Now, conditionals, again, just if, else statements. We use colon instead of curly braces, and you need to indent instead. Now, what this is important in showing is that, let's say that, we wanted to say, if, let's say we have some variable I equals like, let's give it a number like 7, right? And then let's say we wanted to say like, if I is greater than 7, do this. Otherwise, if it's less than 7, do this. Now, in Java or C, you would type like if I greater than 7, then this is not Python syntax, by the way. I'm just typing out what it would look like in Java. You do, or not Java, well, some weird hybrid language. You would like print like I, otherwise, right? So this is how you would do it. And these curly braces are what define code blocks. Now, for those of you who have done this before, you'll know that the indentation is a style choice in such languages, right? If I do this, it doesn't actually matter. It'll still parse everything perfectly fine, and you'll still be able to get a good else statement. This is not true in Python. Python is heavily reliant on the way that you indent things. It in fact has language errors for indentation errors. So let's say, so as I said, instead of curly braces, we use the colon to determine, and then we indent, right? So let's say I type something like this. This is going to return an error, which you'll see right now. And it's an indentation error. Basically, again, we need code blocks to be indented in. So what it's looking is it's going like, okay, so this is the level indent for anything inside the if statement. This should be consistent with anything inside the else statement. So then it looks at the else statement and goes, oh, that's not indented correctly, but I expected something, so there's nothing under the else statement. However, I expected something in the else statement, so okay, someone clearly made a mistake with indentation, and then it tells us, okay, you made a mistake with your indentation. So as long as you make sure your indentation is consistent, you can then do something like this, and you can see that it'll print us the correct value. So, because it's 7, in this case, I is, not greater than 7, so it's going to print red. But yeah, that's the entire idea, is make sure that you're consistent with your indentation. Otherwise, you can get yourself into a whole heap of trouble when you're writing like really long pieces of code and you get an indentation error and you're looking through it. You're like, where the heck is something wrong? And you just left a space in or something like that. Just ensure that you're consistent with your indentation all the time, so that way you don't end up with annoying indentation errors. But yeah, as for the technicalities for defining conditionals, it's just kind of if. I mean, it's the same words. It's if, condition, else, do this. The only little difference is that instead of else if, it's elif, just because Python wanted to be different again. So just, instead of typing else if, you just type elif. Yeah. Next up is lists. We've included a quote from probably Nelson. I feel like Fauzi would have said this as well, but like, array lists are like arrays on steroids. And lists, as actually this is a quote from Samrat, so it should say Samrat, but in any case, lists are like array lists on steroids. Now, what we mean by that is essentially this: because Python is dynamically typed, you don't have to type in the name of a you don't have to type in like the type of a list. So I can have a list of random items. Let's call this list like, X, right? I can have a list of different things that can have stuff like, a string in it, let's say my name, or it can have, a number in it, like, 42, or it can have a Boolean in it, like true, or it can have, another list in it even. So I can throw something like, this, and then just fill this up, and you can go on and on and on and on and on. But in general, lists can just store random stuff in. Now you'll see when I print this out, it'll just print out everything in it. So print out, okay, it's a list with the string fill, number 42, the word or the Boolean true, and then the list 1, 2, and 3. Now, the way that lists work this way is that, they technically just store objects. However, in practice, you're going to want to ensure that unless otherwise specified, you're usually going to have your list be all the same type. So you can sort of like this is sort of like a fun thing you can do, but like don't really worry too much about the fact that it can happen, because usually when you do stuff like this, it causes errors. But the point is that it's possible. Now, the other thing is that because in Java and C, you usually want to declare, like when you declare an array, you have to declare the length, right? So I'd have to do like int this x is equal to, well, actually in Java specifically, you would type new int, like let's say it's 42 length array. You would type something like that. Python, as we saw earlier, does not have that. I can type x and I can make it equal to, you know, whatever. Make sure that your commas are right. I can have it like that, and then, you know, cool. And then let's say I wanted to add something to it. I'll show you all these functions later, but like I said, I want to add something to it. I would just add the number 456. And you can see that when I print out x again, it has that thing in there. So there's no size limitation on it, simply like an array list. But unlike, you know, array list or really anything in Java or C or stuff, there doesn't need to be a specific typing for each one of the, there doesn't need to be a specific type depending on which list you're using. Now, in terms of operations on lists, I'm just going to go back to here. Did we talk about them? No, we didn't. Right. So in terms of operations on list, let's take this list. Let's reinitialize x to be just something empty, right? Sorry. Need to add a bunch of code cells. Let's want x to be something empty, right? Let's say I wanted to add like, you know, a couple numbers to x, right? Or let's say I wanted to add like the number 5 to x, right? I wanted to put 5 into the list. Well, I would just use the append function. So x dot append, and this adds it to the end. So sorry, you need to use parentheses because function in Python use parentheses. We'll talk about that later, but you just do that. You do x dot append, and we're adding number 5, so you do that. And then if you print out x, well, I ran it twice, so it does it twice. If you're asking why it did that twice, well, I ran this cell twice. So it appended 5 to x 2 times. You'll see if I run it again, it'll do it a third time. And yeah, so on and so forth. So I'm just gonna kind of have some fun here. Yep. So yeah, we've added 5 to x a bunch of different times. Now say I wanted to remove 5 from this list, right? I wanted to remove the number 5. Now you'll see we'll actually run into a problem here, but I'll show you first. You would just use the dot remove, right? And then you put in the value you want to remove. You can see the little tooltip here handily. I'm pointing at a monitor, as if you can see what I'm pointing at. But you can see the little tooltip handily tells you it'll remove the first occurrence of a value, which is what I'm aiming at later. But you see, we just do dot remove, and then we print back out x. And you can see it's missing one of the 5s. However, remove does not remove every little thing from it. It only removes it only removes the first occurrence of that item. So you'll see if I run this again, it'll remove one more 5, but remove will never remove all of the 5s in a list. Or all of a certain value in the list. It'll only remove the first occurrence that it runs into. There are other methods for doing that. I don't know them off the top of my head, but in general, we'll provide you with links for this later. But what you need to do is, not need to, but what you really should do is, if you want to get better with Python, look up like the documentation for how lists work, and you'll be able to know. Also, I've seen the chat like kind of pop up. I'll say there will be a time for questions later. Feel free to throw them in the chat. I'll answer them at a different time. I'm going to get through all of this first, and then I'll start, you know, answering questions. But assuming those are questions that are popping up, but yeah. But, you know, you just kind of remove the number 5. It just kind of removes the first occurrence. The next thing is obviously how do you index the list? Well, let's say I want to get the second. Let's make the list something different so you can actually see things. So no 1, 2. Right. Let's say I wanted to remove or to, you know, get the second element in the list, right? Now, first things first, for anyone who's familiar with computer science, we start counting at 0 because we just chose to do that. So we start counting, we want the first position, so the first element in the list corresponds with the 0th, it's a weird word, but 0th index. So you want to do, so if we want to get the second element, they'll correspond with the first index. So we go at index 1, type x1, and that'll give you back, you know, you'll see the number 2 gives you the second element in the list. So in general, when you want to grab something from the list, so let's say I wanted to do, you know, the 4th element, or well, yeah, the 3rd element, or no, sorry, let's say I want to do the 4th element, right? That'll be at index 3. and you just do bracket number, whatever, and it'll pop out, whatever's at that point. And then lastly, again, this is not comprehensive, but lastly, like the last like main operation for lists I'll cover is, let's say we wanted to go figure out a number. Let's say we wanted to figure out how long our list is, right? In some cases, you'll be given just input giant lists of, say, like a large number of elements, and you won't really know how long it is, but that size will be important. So what you do is you type in len, and then you type in the objects. And as you can see from the tooltip, len in general is just like a general Python function that'll tell you the length of any sort of data structure you're using. But in the case of lists, it'll literally just count it up. And so you can see, okay, there's five items in the list. Therefore, the length is 5. And so these are like, for like often used functions. There are a lot more that you will be using often because lists are extraordinarily important for machine learning in general. So as I said, we'll give you links at the end of the slideshow. If not, they will be in Discord. And the idea is, please, like, if you have time, feel free to read them on your own time so that you can better understand, different functions that work with lists. So that's all I really wanted to cover for lists. Moving on next to functions. In Python, now we may not be using functions like extremely often, but you will be using them a decent number of times. But in general, functions in Python have this sort of construction where you do def, which is short for define. You would do the function name, you do parentheses, the parameters of the function, and then you make a new code block. So you do a colon, then you do an indent. Now I'll show you this soon, but you actually don't necessarily need to have a return statement on a function. For those of you who are from programming languages that do that, you can just have functions like mutate something without having to, or just change something without having to return what happened. But in Python, you can type return. You don't have to, but we put it there because we could. Oops, sorry, that's too far ahead. But okay, let's say I wanted to make a function that that prints out takes a string and prints out the third character, right? So first things first, I should actually note that strings are kind of like, they're under the hood. They're kind of that you can treat them like lists somewhat. So if I wanted to pick the third character of the string n, right? I would just do n, third character would be in position 2 or index 2. You print that out and you can see prints out the I in fill. So you can just index them the same way that you would lists. So let's say that I wanted to make a function def third index. Side note, as I'm doing this, you guys should note, in Python, things have underscores. We don't use camel case, if you know what camel case is versus snake case or whatever. But in general, you use underscores instead of camel case because that just makes things much more readable, in my opinion. And also, that's just the Python convention. In general, if you're doing something for your projects later or when you're writing your code, you just want to keep it consistent, but camel case just looks ugly. So please use snake case. Also, if you think camel case looks good, I don't know what the heck to do with you, but that's your own choice, I guess. But yeah, so let's say we wanted to figure out whatever's in the third index of a given string, right? We want to give it the parameter s, and then colon, and we start a new code block. Now, let's say we just want to print it, right? Let's say we don't want to return it, we just want to print it out. So we just print s, and then third index of s, right? And so then you go through, and that's the function defined. And so now we want to take, let's throw in that string, let's throw in my name into this function. So we'll do, do third index of string n. Then you can see it'll print out, oh, I added one, as I said. See, even I make these off by 1 errors as well. But yeah, when you're doing this, remember third position equals second index. So you do that and you'll see, boom, it'll give back an I. Now, let's see if I wanted to throw in another one. So also, I'm going to rename this the third letter because I realize now that's actually a smarter way to name it. This is what happens when I code things on live. It comes out a little scuffed, but worked out. We can just run these again. So run. Let's do third letter of, I don't know, let's type in our president's name, guys. If anyone who doesn't know, Sadesh is the president of this club. So let's type in Sadesh. It should give back a D, as you can see, gives back a D. Now we can have this return the thing as well. I could also just write as easily. I could also just write this as return S2, but my point was that you don't necessarily need a return statement. You can have it if you need it, obviously, but you don't necessarily need it if just mutating something in place, or, as an example, or just changing around like an element in a list. You don't necessarily need that. But yeah, that's the skinny of functions. So just, def, function name, parameters, and then make a code block, put a return statement if you need it, so on and so forth. Next up is loops. Now, we have for loops in Python are a lot simpler than in Java. And as we've written here, they're closer to for each loops in Java, if you're familiar with what those are. In general, the idea with the for loop in Python is that Python has these objects called iterables, which you really don't need to know the specifics about what an iterable is. Just know that an iterable is kind of like a list. It's like a bunch of different items that are, that can be, it's like some sort of collection of items. So say that if I wanted to do something like n times, right? So I would do for I in range, let's say 5. You can just print I, and this should print out anything from 0 to 4. Boom. Now, quick aside on range, in general, you can range you'll do from start to finish. And then the third number will be the number of intervals. So if I do from 0 to 5 and then print every second value, you should see this should print out 2 values. Or 3, sorry, can't count. But yeah, it will print out 0, 2, and 4. But in general, when you use the range function, it's left inclusive and right exclusive, which means that if I would say print out a range from 1 to 5, this will print out 1, 2, 3, and 4, but it won't print out 5 because it prints out these 4 values. And that's just how range works in Python. But as I said, you don't necessarily need just range, right? You can do any sort of iterable. And so what's really helpful is that lists are considered iterables. So say I have a list of names, right? Let's make a list of names. I'm gonna grab people's names from the Zoom thing. So sorry if I butcher pronunciation, by the way. I am very bad at pronouncing things. I'll throw in my name, Phil. Let's see, Leo's someone here. Yeah, cool. I can't type. Oh yeah, I missed it. Leo. And then I'll throw Sadesh, why not? And I'll also make some rep because I can. Great. So let's say we have a list of names here and we wanted to iterate over them, and let's say we just wanted to print out every single one, right? Actually, let's say we wanted to print out the third letter of every single one, right? So we've already made a function that prints out the third letter. I'm gonna fix that real quick. Right. We already made a function that prints out the third letter of every string. So let's do you can do for name in names. Third letter name. Right. And you can see this will print out the third letter. And did I do that right? Yeah. Oh yeah, I did, sorry. Yeah, so you can see what this does is it iterates over the list of names. It grabs each name, so each cycle it goes, okay, so first name, okay, cool, it'll be on. We'll assign that to the variable name. Okay, find the third letter of that, print it out. Phil, we'll find the third letter of that, print it out. It iterates over each element in this list. So in general, as I said, for loops will iterate over elements in an iterable. So range is an iterable that'll spit back, numbers from 0 to n minus 1. If you do a list, it'll just go over all of the elements of a list and so on and so forth. But in general, you just need to give it some sort of iterable collection and it will spit back. It'll return that into your iterator, which is, this variable here, names, or in this case, it's I, and it'll just do whatever with it, which is whatever you put in your loop body. So yeah, now we didn't include this on the slide, but I'll just be quick. While loops are just really simple, they're the same thing. So you can just do while I equals 0, or I equals 0 while I less than 10. Print, throw a random string in there, why not? And then and you can see this will print out lol 10 times because yeah, it's the same thing as, in other languages. It's just, with the whole Python idea of colon and then put a code block in instead of doing, brackets. But yeah, that's the idea with loops. Now, that should be it in terms of Python, or like that should be it in terms of just like, Python constructs. I know that was a lot of information, so we're just going to stop right now. And before we continue into the exercise, which we'll go into shortly, I'm just going to, go ahead and answer any questions. If you guys have any, feel free to throw them in chat, or to, throw up the, or to like, throw up your, just, unmute your mic and talk them out. But anyway, so yeah, so thank you for answering. Yeah, true equals false is valid and acceptable. It's acceptable in terms of Python syntax. It is not acceptable in terms of my heart. You write true equals false, I'm going to get a couple of, it'll kind of, it'll probably make a couple people puke, so maybe don't do that. Boolean values are capitalized, yeah. Somewhere that what IDE. VS Code is great. PyCharm is cool. As I said, we'll be using Google Colab, which in general is just kind of a it's like a notebook. So if any of you are familiar with like Linux or like using a terminal when you're for like like a REPL or read evaluate loop, basically it's just you can make little cells of code and you just execute them and they'll come out with the outputs the same way I was just doing now. But yeah. Do we get PyCharm through the school? Yeah, you actually get PyCharm Professional. You actually get PyCharm Professional Edition through the school, which is kind of helpful, I will say. I have it installed on my own PCs, even though I don't actually use it. I use VS Code for, just full honesty there. But PyCharm Professional Edition does come as part of Beacon School. You can type in your UMD ID or UMD email into JetBrains. Oh yeah, so Terpware. If you go to Terpware, if y'all aren't familiar with Terpware, then just search up TERPWARE, and this should have instructions on how to do that. Otherwise, you just need to. Otherwise, if you can remember me just talking about, you go to JetBrains' website. JetBrains is the company that makes Python or makes PyCharm. Not Python. Python is open source, but PyCharm is made by JetBrains. And you go to there and you register an account through your UMD edu email. So you would type in my case, it would be pmatthew@umd.edu. And you make an account and it'll recognize it's a student account. And as a result, we'll give you a free subscription to PyCharm Professional, which you have to renew every year. They'll send you emails about that. But as long as you're at the University of Maryland, they will give you do have PyCharm Professional through that way. I will also say, because it's kind of a consideration for people, if your computer has very low memory, I do not recommend PyCharm or PyCharm Professional. I honestly recommend VS Code. In general, Python development can be kind of a memory intensive thing, but JetBrains, PyCharm specifically takes up a lot of memory. VS Code takes up a decent amount if I'm going to get someone who's going to yell at me about Vim or Emacs. But I'm not a Neanderthal, so I'm not using either of those. But if you're gonna use something like, if you want to use something like VS, if you're thinking about using VS Code versus PyCharm, PyCharm takes up a lot of resources. So if you're kind of strapped in RAM on that, I would recommend going with VS Code. But yeah, does anyone have any other questions, syntax related, or Python related, or I don't know what I had for breakfast? I guess I don't know. Like any questions before I continue into the exercise? I will assume that means a no for now. Again, I'll have a Q&A after this, so feel free to ask me questions then. But for now, what I'm going to do is I'm going to move on to the, so resources. We'll post these slides for you guys, so you'll have it. But these are some resources that you can use. Also, in general, Python itself, like on their website, has really good documentation. So, look at that. But you can always, there's always resources for Python. But yeah, Samrat put a meme in there. You guys can tell me if it's funny or not. But yeah, that's the meme. But yeah, so before we end, let's first do a quick exercise. So let's say I wanted to make a function that printed out a list of all even numbers from 1 to a given integer n, right? How would I go about doing that? You guys can type in the chat, you can unmute and tell me what to do, whatever. but I'm just going to let you guys figure out how to do it and just tell me what to type in, basically. So how would I go about doing this? I am free to continue this awkward. It's right. It's screen sharing with you guys, right? It's the same one right here. Create a function that prints out a list of all even numbers from one to a given integer. Okay, sure. So Leo suggested doing something like while I is less than n. All right, that's a good start. Let's say while I less than n, blah, blah, blah. Okay, what else? Print 2 times I, or we do while I, so you know what? An gave a good suggestion, and Leo, that's also a smart way to do it. So, you know, we'll do both. I'll type in on, keep that in mind. I'll ask you, how you wanted to do it later, but I'll just go with what Leo said for now, just because while we're here, it's quicker for me to type. Honestly, there's no other reason. Yeah, print 2 times I. This is close, but this is not a function. It's just a loop. What do I need? What do I still need to do? We're missing a couple pieces, obviously. For I in range 2 and 2, okay, that also works. Yeah, okay, thank you, Tim. That's what I need. That's what I was waiting for. Right, we need to define a function first. So I'm just going to call it print evens because I think even maybe a reserved keyword, and if not, I don't want to risk it. So print evens. Do we leave the parentheses like? Oh, sorry, yeah. Make sure that everything's indented. Do we leave it like this? Is this fine? What do I need to do? Is there anything I'm missing? Parameter. Yeah, Vedant said a parameter. So yeah, we need to put, as An said, we need to put a parameter n, right? And we're still missing just one last thing. What are we missing here? Increment I by 1. Well, that's another thing, obviously. Can you tell I don't use while loops much? We're missing 2 things. Forgive me. Also, by the way, I've been kind of avoiding them just because I didn't want to make things confusing. But Python also does support things like plus equals or minus equals and stuff. Funnily enough, Python does not actually support plus plus. So if I type in I plus plus, that does not increment I. I actually do have to type in I plus equals 1. So remember that in the future, but just one of those quirks. It doesn't have I plus plus in there. But are we done? Is that it? Sam, if you look at it, the way that we're doing this, we actually don't need to check whether I is divisible by 2 because the way that we're doing it, we're just taking a number and we're multiplying it by 2. So it will print out an even by default. Does I have to be less than n over 2? Yeah, sure, whatever. Why not? We'll do that. Oh, no. No. You want even numbers from 1 to n. So, if we're going from 1 to 10, we would print out 2, 4, 6, 8, 10. But Vaibhav did nicely put in that we need to put in I equals 1. Yeah, that's the thing. You guys, that's the thing that we missed, is that we need to initialize I. Now, ideally, this should work, as we all know with code. High chance it doesn't work because, first time it never works. So let's try this out. Let's say from print evens. I don't know why I put the print statement around it. I actually don't need that. From, let's say it'll go from 1 to 10. Cool. This should 2, 4, 6, 8. Ooh, close. Wanted to print out 10 as well. What are we missing here? Less than or equal to. Yep. Thank you, Yazid. Right. Do less than or equal to. So type that in. Boom, we're done. And let's fix this now. So we printed out all of these, right? But I realized we didn't make it into a list. We actually want to put all of these into a list. So how would we, return some sort of list of even numbers that, gets printed out? How do we do all of that? Define a list. Okay, what do you want to call the list? You guys are doing everything. So what do you want to call it? Like L, Z, what? True, Leo, I'm gonna die. Yeah, okay, we're gonna get red. Thank you, Vaibhav. Do not call anything true, please. Oh my Lord. Yeah, so we'll call it ret. And then said append instead of print. Yep. So you want to do ret dot append. Lovely. And then, append has a D in it. Usually I can type. And then if we type this, yeah, print list. Cool. I'm just going to instead of printing, I'm just going to return the list. And then, not that will return. Lovely. We'll just do that and we'll watch and boom, that works. So yeah, as you guys can, Soham, I swear to God, I knew you're going to say something annoying with that. Yes, you can do that. So for those of you who want to look at it, Python has this fun thing called list comprehensions, which will just do X for range in one end effect, which essentially, if you put things between a list bracket, it'll just grab anything. It'll grab, just fix that. It'll iterate through this range. It'll grab the number X and it will say if X mod 2 equals 0, which means if X is divisible by 2, then put X into this list. You'll see this actually does work. No, it doesn't because it's a string object. Yeah, I technically should have put this in. Let's assume A equals 10, but you can see it'll do a similar thing. I'm just gonna make that right. Off by 1. But yeah, I'll go over list comprehensions at a different time, which means I'll put a link to it in Discord or whatever because they're very handy. But we're nearing the end of actually technically we end at 6:15. Oh, whatever. I'll go over it. So yeah, just a quick thing before I continue to just general Q&A is as I said, there's a thing called list comprehensions. So remember how I was saying earlier where with for loops, you can just do for name in names and whatever. Well, Python has something really nice where you can make lists out of that. So say I wanted to make a list of, I wanted to remake the list of names, right? I would do name, right? What this does is it says, okay, for every name in this iterable names, put it into this list. And you'll see this comes out with that list that we had earlier of names. Now, what becomes helpful is that you can add conditions to that for. So as we did earlier, you can say, okay, for anything in this range in a range from 1 to 12, right? Which for any number between 1 and 12, or for any number from 1 to 12, sorry. If that number is divisible by 2, add it to the list. And so what it does, it'll say, okay, cool. So let's go. 1, is 1 divisible by 2? No, so it's not in the list. 2, is 2 divisible by 2? Yes, so it's in the list. 3, not divisible by 2? Not in the list. 4, is it divisible by 2? Yes, okay, it's in the list. And so on and so forth until you get to the end of the range. You can also do this, you can do this for, the name. So let's say name for name in names if name, or if, no, I can't type. Let's say I wanted to add anything that has a length greater than 2, if the length of the name is greater than 2, add it to the list, boom, and everyone's name was greater than 2. Let's make this 3 so that actually, does stuff. And you can see that, An and Leo will get dropped and you have me, Sadish, and Samrat. So yeah, that's the idea of list comprehensions. Again, I'll put a link to them because I kind of just sped through it, but yeah, they're just another handy way of constructing lists in Python. Is there anything more here? Nope, that's all. So with all that, again, we'll be posting links to that. I hope you guys were able to glean something from this. If you have any questions, feel free to unmute and tell me or throw them in chat, whatever the heck you would like to do. But yeah, as for now, that'll conclude our first meeting. So thank you guys for coming, and I hope to see you next Monday. So, yes, Soham, I'll see you later. Yeah, no worries. Thank you, guys.
Sudesh, could you make me the co-host?
Sagar, I'll do that for you right now.
Oh, right.
There you are.
Good.
You are co-host. Cool. Should I stop recording and then like let Sagar start it back up, or? Unrelated topic, but do I have info about BitCamp? I did not know that BitCamp was happening, so sorry, don't think I do, Vedant. Sagar, Sudesh, do either of you know much more about BitCamp?
No, I don't.
Okay, yeah, rip. Vedant, I will say, given that none of us seem to, if you do have it, you can feel free to throw it into like the self-promo channel in the Discord or whatever, and just, whatever about BitCamp, because I feel like, yeah, a lot of people would want to join it, but yeah, I can't say that I know anything more about it.
Well, we want to stop recording and then start when.
Yeah, I'll stop recording.